a dance of specks of dust in the light. Such an effect can be observed even in the most thoroughly cleaned room. Not thousands, not even millions, but billions of particles, each one which can be fatal in the case of high requirements to air cleanliness. Control and minimization of air contamination in such fields as medical, semiconductor, pharmaceutical, biotechnological, aerospace, food, cosmetics, and many other industries is carried out using clean production rooms. It is structurally complex and highly expensive equipment, ensuring required cleanliness class in accordance with ISO standard. One of the efficient ways to decrease costs during clean room development is zoning of the facility into local areas called clean zones. A clean zone is a local enclosure designed as a room inside a room. The main purpose of the clean zones is protection of a product from external contamination and maintenance of present air cleanliness parameters in a local work area. The clean zones have the following advantages. Can be used in a clean as well as in a regular room. Clean zones are compact, therefore they can be used almost in any room. Clean zones ensure the same level of cleanliness as the clean rooms, but are significantly more cost-efficient. Clean zones are mobile and can be used where it is required at the moment, as module structures that can be assembled and disassembled. Clean zones are used in all industrial fields that have high requirements to air cleanliness. Types of zones as per cleanliness class. The major configuration difference of one clean zone from another is its air cleanliness class. For instance, in a clean zone of ISO Class 5, the ceiling is completely made of filter fan units. The cleanliness of the work area is ensured by forcing contamination away with unidirectional clean airflow, referred to as air piston effect. Along the periphery of the zone, there is an enclosing structure elevated above the level of floor to ensure the exhaust of airflow. A clean zone of ISO Class 7 and lower has only a few filter fan units. Their number is determined based on the required number of air changes inside the clean zone, taking into account its configuration and dimensions. A low turbulent airflow is supplied into the clean zone, ensuring air cleanliness by diluting, reducing the concentration, and removing the aerosol particles. The configuration of the ceiling in this case is based on raster principle. Its meshes are equipped with filter fan units and lights. The rest of the area is closed with top panels. The work area is defined with enclosures fixed along the periphery of the clean zone and extended down to the floor level. To ensure positive pressure inside the clean zone, its enclosure is equipped with transfer grid or anemostats. Filter fan units. The main component of any clean zone is a filter fan unit, shortly FFU. Using forced recirculation through the HEPA filter, the filter fan unit cleans the air that is supplied into the work area. Structurally, the filter fan unit consists of supply preliminary filter, high-pressure chamber with centrifugal fans, HEPA filter, laminarization screen or turbulator, electronics module, filter testing system. Completed with laminarization screen, the filter fan unit creates a unidirectional airflow with uniform velocity, the so-called laminar airflow. The filter fan unit with laminarization screen is equipped with LED lighting system that does not create barriers to airflow. Completed with turbulator, a turbulent flow is created for better air mixing in the working area. All the filter fan units are equipped with advanced fans produced by German company EBM Pabst. Electronically commutated motors that are used in the fans are silent and energy efficient. Using several fans on a single unit increases the uniformity of the airflow, decreases the level of noise, and significantly reduces dimensions of the filter fan unit. The height of our filter fan unit is only 315 millimeters. An electronics module controls the fans, maintaining the airflow velocity independent of the level of filter clogging, controls the lighting, indicates when filters need to be cleaned or replaced, generates an alarm in case of emergency situations. For HEPA filter and its sealing integrity testing, there are special inlets for testing aerosol supply to each fan and outlets for sampling the air from the positive pressure plenum. Location of the inlets and outlets allows carrying out all the necessary procedures inside the clean zone. Enclosures. Enclosures form the work area of a clean zone. and isolate it from the external environment. They are made of metal frame with fixed panels. The panels can be made of tempered glass, coated metal, or a combination of both. Additionally, anti-static PVC strips can be used as an enclosure. In case it is required, a single clean zone can have all types of enclosures. All of them are highly resistant to disinfection and UV irradiation. Frame stands are featured with screw supports that allow compensation of any inequality of the floor. Small clean zones can be equipped with removable caster wheels for easy installation at operating site. Continuous or regular relocation of the clean zones is not recommended, since each relocation requires HEPA filter integrity testing. The enclosures can be equipped with required number of doors, openings, windows, and gates for personnel and equipment transferring. Control. Besides on-off function, the control panel of the clean zone also provides control of the lighting, parameter setting, operation mode selection, and current clean zone status monitoring. The control screen indicates relevant service information, possible faults, and alarms. There are two types of control panels, with a small touchscreen that has a limited number of functions and with a bigger touchscreen for multifunctional specialized zones. Both of the screens allow wet disinfection and operation in gloves. Additional options. A clean zone can consist of several local work areas that have a unified control system and adjacent enclosures, multi-room zone. Moreover, each work area can have its own air cleanliness class, its own lighting, and other functions. Additionally, clean zones can be featured with UV lamps, non-actinic lighting, electric sockets of 220 volts for power device and equipment connection, special voltage sockets, interfaces, pass-through holes, sealed cable ports, exhaust hoods for cabinet installation, fume hoods, pass boxes, and laminar flow cabinets. The control system of a clean zone can have individual activation for separate groups of lights or UV lamps. An individual clean zone access system is also possible. The functional possibilities of clean zones are not limited to the above options, since each project is customized based on technical requirements of a customer and thorough processing of all the technological process specifics and operating conditions. The portfolio of our company accounts for about 500 clean zones, none of which is identical to another. More than 20 years of experience in the area of clean room and clean zone engineering allowed our company to develop its own unique technologies and to create a team of highly qualified specialists that are able to solve the most extraordinary problems.